All right, my friends, welcome back to another episode of the Reisinger build. That's right, we're building this high performance house, start to finish for you guys so you can see all the steps. Now we're in the foundation phase. If you caught episode 3, we did all the underground plumbing. My concrete guy has taken over the job site. We got a bit of a wet, muddy day going on, but we got a lot of details to go over on this job site. I also have my Stego rep on site. We're gonna be talking about the importance and tips and techniques on a vapor barrier, but check it out, the site has changed quite a bit since last time we were here, wasn't it? We've got vapor barrier down, we've got rebar on site, things are looking really good. Today's build show, episode 4, foundation of the Reisinger build, sponsored by Builders First Source. Let's get going.
A Build Original series, in partnership with Builders First Source, the Reisinger Build. This episode is sponsored by Stego.
Okay guys, to catch you up on what's happening here, watch your head by the way. We've got an existing slab foundation and my engineer, Whit, has designed a capping for that, and we've got an addition on the back of the project. So where you see this beam that my guys were just cutting through here, what's happening is we're making sure that our grid pattern for this slab on grade house works, even though we've got this existing slab that's kind of getting capped. On top of the existing slab, we're gonna have 5 inches of new concrete, and we've got a full rebar grid pattern that the engineer has specified, as well as a few places that we're doweling into the existing concrete. Now this is slab on grade. Remember, you could be building this house in the north, and this would be a full in-ground foundation, and the plans are available for this house that we're building here on the Builders First Source plan website. But for this particular case, it's slab on grade, and if you're not familiar with slab on grade, the back of the house where we're building that addition is really like a typical slab on grade new construction would look like. We've set the form boards out, and we made sure that we've put those based on the survey that we've got, because we're in a neighborhood, it's pretty critical. We're right at the 25-foot setback. And in fact, the old foundation on the front of the house was right at that 25-foot setback. So those form boards on the left you're seeing there, they're right at the foundation line that we're basically repouring on top of that exact location. Now in some other areas we bumped out a little bit, including a little bit on the right here, and obviously that back of the house. So the garage is gonna be quite a bit bigger than the original 2-car garage on the house. This looks like a lot of clay that you're seeing here, and there probably is some clay in this neighborhood, but as we've talked about in the past, there's massive rock here too. I mean, once we go down 6 inches, 8 inches, we're basically hitting solid limestone. So this house is really getting dug into the limestone, and it's not gonna go anywhere based on what we've seen in the neighborhood. In fact, I live in this neighborhood, but none of the brick, none of the masonry facades on the front of any of these houses have any cracks. So I have no doubt that this house is not going anywhere as well. Now let's walk up, let me show you a couple things. First off, when we do new construction, slab on grade, and we look at this back part of the foundation, which is new construction, you're gonna notice the concrete guys set their form boards, as I started to talk about, and then they're actually using feed bags, or what you might consider sandbags, filling that with road base, and then the whole center of this got basically filled and compacted with road base. Serendipitous that it's rained on us a couple times. Actually, that's actually really good for this slab because it kind of compacts everything and sinks it down. And then after the plumbers were done, my concrete guys came back and dug the beams in here and basically filled in the rest of the foundation where the plumbing was to get it all set up. Now we had to wait for our inspection first. Before you cover any of those pipes, I had to get my city plumbing inspector out, make sure everything was good, make sure it all met code. And I think I talked about in the last episode, but our emergency drains coming out that side of the house, we added a P-trap, and then we're gonna have a special cap that I'll show you later that will make sure that those drains will drain on there. There's not that much plumbing in the slab. And I do wanna mention there's one piece of copper that is not water pipe. See this copper right here, which is running on top of the slab and sticking up over there? That's going to my water heater closet, and that's gonna be the T&P, basically the pressure relief drain. So if that tank ever had a problem, it wouldn't blow up, it would release that pressure. And so this will really never have any water in it, but if it did have water, it's because my tank is trying to explode. And so this is a safety valve, basically. That's not a water line. The line that you see across the garage is the sleeve for the water line. Now the concrete guys have put about half the vapor barrier down in the places where the plumbing is. On the front of the house, we had to dig in some new beams, and it wasn't easy. In fact, you see we just dropped off a piece of rental equipment, and their Mini X sure made that a lot easier to unload off the back of the truck. But that's the basic layout. We are doing something a little different with this rebar. You'll notice this green rebar. You might think it's epoxy coated steel, but in fact, this is a whole different type of rebar. So we'll get into that later in the episode. But I saw that my Stego guy just showed up. Let's take a minute and talk about this lime green plastic that you see on the job site, why we need it, and what are some of the details. So let's go grab Tom. Hey, Tom, there you are.
Hey, Matt, how's it going?
Good, man, good to see you.
Good to see you.
We're looking green out here in the job site.
I know, it looks great.
So for those people watching, Tom, who don't know what a vapor barrier is, and maybe have never even seen your version of it,
sure.
What do we need this green layer for on the house? What is it doing for us?
I mean, gosh, it's pretty simple. It's here to isolate the home from potentially bad stuff in the ground. In this case, we're talking about keeping the home protected and the slab protected from water vapor migration.
Yeah.
In general, though, vapor barriers can be used for part of soil gas mitigation, sometimes for termites, sometimes for VOCs.
Yep.
The typical application is keeping that slab on a home protected from moisture vapor.
Makes sense. And on a rainy day, you know, a good example with my waterproof boots on is, you know, when my boots are hitting this, if we think about this being in reverse, that water's underneath. My boots are keeping that water from soaking my socks.
Yep.
The same is happening here with your Stego home right here. This is keeping any water that's sub-slab below the foundation from migrating up through that concrete. Concrete is a porous material, right? It's not naturally waterproof.
Yeah.
It will soak that water up. And one of the problems, Tom, that I've seen a lot in Texas is that people later have moisture problems because they didn't think about this step. You know, their hardwoods cup, their hardwoods move. They may have other issues with surfaces on top that because of some moisture migration through that slab, they're moving, they're changing, their problems. And this is way easier than trying to do this later on the top of the slab.
Yeah, and what sometimes people don't understand or don't really realize is we can see the liquid water here, but what's also in the ground, everywhere we build, is water vapor.
That's right.
And when there's diffusion and it's going from more to less, it can go through the concrete slab, like you said, because it wants to get into that conditioned building envelope. You introduce a flooring system, the problems can really ramp up.
Yeah, that's right. Let's walk this and talk about a couple things that I'm seeing here. So first off, the guys have taped the seams where the Stego has come together, and they've also draped the material down into these beams like you see here, Tom.
Yeah.
So that Stego is continuous. That's our best practice, right?
Yeah, from a vapor standpoint especially, we want to create a monolithic membrane if we can. Cover the whole footprint. There's project considerations and nuances and things that come into play on all sorts of jobs, and there can be project by project decisions made. But from a vapor standpoint and protecting this foundation, it's a great way to go.
Yeah, we want to get it as monolithic as possible, knowing that there will be some breaks in that, most likely in some way, shape, or form. Now, Tom, I did want to ask you on my outside beams here, we've kind of draped it so that it's just like right here, it's just hitting the bottom. But my concrete guys were worried, hey, we're out of the foundation here. Like if I could jump down here, you can see this foundation is like, look how tall we are. We're like 4 feet out of the ground here. They didn't want that Stego to be showing on the outside. What do you recommend us do in this situation?
And this is a good example of what we talked about, a situation where from a vapor standpoint, sure, it would make some logical sense to take it up and try to kind of protect the whole foundation. But there's an aesthetic consideration. Sometimes we run into structural considerations where it just doesn't make a lot of sense for the engineer to have the plastic, maybe interrupt a concrete to soil bond or something like that.
At the bottom
so
of the
we
beam.
see this quite a bit, no exception taken. And what they're going to end up doing here is actually probably applying a Crete claw tape that we make. And what's nice about that is really anywhere the vapor barrier terminates, you can apply that tape and get a mechanical bond to your placed concrete slab.
Oh, that's really nice. So that Crete claw kind of feels like a bit of a sandpaper product?
It's like a Velcro for concrete.
Yeah, okay, there you go. So that Velcro zipper kind of holds that in place. But the red tape, if you've not used it before, for someone watching this is a bomber tape. This stuff sticks really, really well. Now we did stick this in dry conditions, so I will tell you that it's gonna be hard to stick if this Stego is wet, but this is really gonna bond those 2 layers of Stego where we had a break in there. Now this is the 15 mil version. You guys also make a 10 mil version, if I remember correctly, on the Stego Home.
Yeah, this is our Stego Home product. It's a little bit of a newer line for us. A lot of people are familiar with Stego Wrap,
yeah,
kind of our
yellow
flagship product.
Yep.
This is designed for this kind of footprint in mind, a smaller residential, usually single family home. And for even a trade crew like this, we got 3 or 4 guys out here. They've used both products before, and they were telling me earlier, gosh, this was the way to go. Lightweight, smaller rolls, easier to handle for the installation, and they also noted reduced waste.
Yeah, I do want to mention this Stego Home is a smaller roll size. It's less wide, whereas if you're doing a giant commercial job, you want those giant rolls.
Absolutely.
In effect, though, this green material is the same as the yellow that I've used in the past.
Yeah, and industry-leading performance, you're getting that with both products. And we've got other barrier solutions. Really, we think for any foundation type, any building size, any soil threats.
Yep.
This one here was a good fit for this project.
Makes sense. Now, what's the difference between Stego and, for instance, like this original 70s pour had some black, I don't know what mill it was, pretty thin poly that looked like it was pretty torn up.
I mean, that's probably the biggest question we get. You know, in terms of composition, there's some similarities, plastic film essentially, but it's in terms of the material, the raw material that go into it, the quality of the resins, the layering of the film, that can make a big difference because not all plastic sheeting is created equal.
Yeah,
so generic 6-10 mil clear black poly, use it for 1 million applications.
Yep.
It's just not usually suited for long-term protection under a slab.
It's gonna be a little hard to tell for these guys, but one thing that I really like about it, I mean, this is a tough material. You're not ripping that by hand. You could puncture it, don't get me wrong, but like, for instance, the concrete guy dropped a bit here. I could step on that bit all I want and it's not puncturing that material, and that's why I like this thicker material. It's a little harder to use than a thinner material, which is gonna drape easier. You can see it's not gonna ball up easily. This is the 15 mil.
Yep.
But I like that 15 mil. I like to go a little thicker. And again, I am worried about moisture coming up through my slab and causing problems later on. So this, as much as I can, as consistent as possible, we're gonna try and tape the seams. I do notice I've got 1 or 2 things that I could use some mastic on. For instance, this rebar that's sticking through, we could use some mastic on this rebar.
It's kind of the good news about water vapor diffusion. Stakes get a little bit higher when you start using these systems as part of soil gas mitigation systems.
It's a great point. Yeah. It's a great point. Now, I'm not using really anything on this house for mitigation of soil gases. I'm in a very low radon zone, basically the lowest zone in America on the EPA map. So that's not a big deal for me here, and it's not an in-ground foundation. But if you were doing that, you would want to make you'd want to make those next level of detail higher. Like my friends up in the Build Show Build Boston did on that series, if you haven't seen that one. Anything else we need to know about Stego in this particular application that we've missed showing these guys?
Maybe it's just worth noting that, things are changing in the industry with this part of the building enclosure. Codes are changing, guidance in the industry is changing. I think we're catching up a little bit more in the residential world to where we've been out in the commercial world
for sure.
For 20, 25 years.
It's pretty standard to see this in the commercial world.
So, this is a material that meets a certain performance standard. It's ASTM E1745. You actually see that now referenced in the building code, the residential code. And so this is kind of coming in terms of higher performance, more thoughtful approach to isolating homes from bad things in the ground with effective vapor barriers.
Yeah.
And if people have questions, there's great information on the Build Show site, or come find us, and we're happy to be a resource.
Now, one thing I want to mention, Tom, is we did not use the termite barrier version here. I did make a video a while back on doing that. I'm going to be using Termite Mesh. Stay tuned for some talk about that in the future. But you guys also make a termite-proof version. You make a brownfield version. You make a version of this that's intended for conditioned crawl spaces. So you have lots of different things in the Stego catalog for that high-performance builder to really do a top-notch job. And they make bomber products. So Tom, thanks for joining me on the job site, brother.
Yeah, you got it. Appreciate it.
So next up on this episode, guys, we're going to be finishing the Stego. We've got a lot of rebar to do, and then I got to bring my electrician in. We've got to bond the slab to the rebar, and I'm gonna show you how to do that with this special type of rebar. We also have some termite details we need to go through, and these concrete guys need to get going again, and it's about to get loud, so let's let them get back to work, and we'll see you back here tomorrow. All right, guys, welcome back. A lot has happened. We've made some great progress on this slab prep. I want to talk today, or specifically in this segment, about some cheap insurance that I've been using over the course of time with a stainless steel product that you may not know about. I got my termite expert Joel on site and Juan doing a little work for us. Hey Joel, how's it going, dude?
Hey, how are you, Matt?
Good to see you, brother.
Good to see you as always.
So Joel, termites, an insidious pest that causes massive damage over the years.
Yes.
And most builders do some type of chemical pre-treat where prior to pouring concrete, you got to get a termite guy out like you, dump, let's say 100 gallons of chemicals in all the footers prior to pour, and then you provide a letter to me that I give to my inspector that says, we pre-treated with such and such treatment on such and such date.
Yep.
I'm not a fan of that, not because I'm some green police, but honestly, I just don't love that it doesn't last forever.
Correct.
Right? And of course there could be a case made to say, hey, there's chemicals that get into the watershed, but my issue is that within a decade we got to redo that.
Correct, and that's, most chemicals are 5 to 7 years. The higher dollar value, such as a Termidor, is 10 to 15 probably.
Yeah, and Termidor is a great product.
It's a great product, especially if you get active termites on your house.
Yeah,
it's
you
a
should
wonderful
use it.
product.
Yeah, we're not disparaging that by any means.
Definitely.
But on the other hand, you guys have been installing this on my jobs for like 2 decades. What is this?
So since 2000, we've had the rights to the U.S. For Termite Mesh. Termite Mesh is an Australian product developed there when they eliminated chlordane.
Okay.
And basically, it's a fine stainless steel mesh that is too hard because it's stainless steel for termites to chew through. It's the holes and apertures are so small the termites can't squeeze through it. And the best thing is, once it keys into the concrete, they can't go around it.
Yep.
We're making this concrete slab a solid barrier.
A monolithic barrier that they can't
Yep.
get. Now I do want to mention that I really want builders to know that they need concrete showing on the outside of the foundation. We topped this existing slab with 5 inches.
Yep.
We talked about that in a previous episode here, the Risinger build. But it's interesting to see how we're pretty high out of the ground. We're 2 feet probably on this side of the house over here, but we're not more than about 8 inches on this side, and that's about the minimum I want to see. I don't want that stucco, that siding, whatever, an inch away from the dirt. That's a bad idea. Those termite tunnels, if they do come up on the outside, you're not going to see them, and they could easily cause a lot of damage before someone realizes, oh shoot, I've got a termite issue at this house.
Exactly, exactly. Anytime you give them hidden avenues, they're going to take it.
Yeah,
because it keeps them out of the way of predators and also allows them to go about their business.
Yep. Now Juan's pretty dang fast at this, I gotta tell you, brother. That's impressive. He's knocking these out. And if you guys are in Texas watching this, they can do this for you pretty much anywhere in the state.
Yep.
However, if you're not in Texas, there's another option for people, right?
Correct. We actually, we sell these direct on termistopUSA.com. Basically, we have all the usual pipe sizes, so whatever you need, we have. If there's a specialty pipe you have for some kind of unique install, we can prefab that for you here in the Austin warehouse.
Yeah, makes sense. And these guys are pretty affordable too, like 15 bucks a pipe-ish, maybe a little bit less. And if we're all as fast as Juan, we could do the house in 30 minutes. That's his. I love it. He's waiting on us. I mean, it's pretty straightforward. We'll probably not be as quick as Juan to do it, but for the most part, there's not a whole lot to it. I do want to mention though that he's putting these in a specific spot, right? He's not putting them up here. They're in the hopefully rough center of the concrete. That doesn't have to be so specific, but as long as we're down below the top and above the bottom, we're looking for that concrete to key in here, mesh around this, so that when a tunnel happens, when a termite comes up this direction, they're going to hit that physical barrier and they won't be able to come around it because that concrete's in the way, right?
Yeah. The key is, as long as the edges are in the concrete.
Yeah.
It's once they key in, it's over. They have to go find a meal somewhere else.
Yeah, that makes sense. Joel, we're gonna have you guys back when we get into framing to actually do a non-chemical, all-natural treatment as well. So we'll stay tuned for that. Just a little a teaser on that. We're gonna use a boric acid product on our framing at the bottom couple feet as well. So we'll get Joel back when we get into framing, but great job, brother, appreciate it.
As always, thank you.
For sure. Guys, we're gonna come back and talk rebar. I'm meeting my engineer out here. We got a lot more to go, so we'll see y'all soon. Okay, y'all, big day here at the Reisinger build. This is pre-pour inspection day. We're about 2 days away from pouring the slab. We're like 98% done. I've got a city inspection called for today, and I've got my engineer on site. Where I am in the city of Austin, they require an engineer's letter that says, yes, I designed it, and yes, it meets my design. I've looked at it. So I actually have Whit Smith with Smith Structural Engineering here on site. There he is. Hey, Whit.
Matt, how you doing?
Good, man. How are you today?
Good.
Good to see you.
Yes, sir.
So we're about 98% Whit. I noticed 1 or 2 things that we need to button up, but overall, what do you think?
Looks looking really good.
Yeah, it looks pretty much like you designed it, right?
Very close.
So I got to mention first off, I know people are seeing this. We've got this kind of weird rebar going on down here, Whit. This is not your traditional black steel rebar, is it?
No, this is fiberglass rebar.
So this is MST bar. A little bit different than a standard bar, and a couple advantages and maybe even a couple downsides that I want to mention real quick. But before we jump into that, Whit, for people watching this who are not familiar with slab on grade construction, how do you explain this foundation to somebody who's never seen one of these before? You know, somebody watching this in Minnesota has never seen one of these.
This is a typical stiffened slab on grade. What that means is we have grade beams, perimeter and interior grade beams. Those are our stiffening beams. And then we have a slab poured monolithically with them that ties them all together.
Yeah, so no separate footing and then walls like we might see in the north that are tied together with rebar. This is all one monolithic pour. Whit, I like to explain this and kind of use the example of a concrete parking garage. You know, you think about your truck driving on that garage. It looks like concrete when you look down, but in fact underneath your truck is air. And you've got structural beams, you know, with concrete and steel underneath your truck, and then you've got columns that are bearing the weight. I kind of think of this slab in the same way, where the beams are carrying the weight, and then everything in the center is a structural stiffened area that in effect could have air underneath it, but in fact we've got compacted fill here, right?
That's right, yeah. We like the compacted fill as a second assurance. You know, that's a kind of a belt and suspender approach.
Yeah.
But the idea is that the beams are stiff enough, rigid enough that it can carry the load from the slab and transfer it out to create one big rigid foundation.
Yeah. Whit, on our last episode, I saw several of the comments that people said, you know, what's up with these weird sandbags and how does that make sense? Like, how could you possibly have a compacted area of fill underneath with sandbags? How do you explain that to somebody?
The bags, they're used to create our beam trenches.
Yep.
So unlike a commercial pad where you build the pad first and then come cut the beams in second, in residential construction it's more common to set a form and bag the inside of the beams and then fill up to it.
Yep.
There is a concern that you don't get the same level of compaction near a bag, but what we have found is if you do it in lifts, if we install, let's say 2 bags, bring in a lift to fill and compact it, another bag or 2, compact it, we've taken density readings, you know, in close proximity to the bags, 2 to 3 feet away, and we still meet our densities that we're looking for our projects. So.
Yeah, I like that. And then I mentioned on earlier episodes, we're pretty rocky right here in this neighborhood. So I think if I remember correctly, in your general notes at the beginning of the engineering, it says embed at least 6 inches or maybe a foot into the rock, into the existing grade. Is that generally true on your projects?
Generally, yes. If we're in rock, we ask the contractor to go down 6 inches in a rock, and then they can stop.
Yeah.
You know, we don't want to be removing feet of rock only to put concrete back in its place.
Yeah, and back to that explanation for the northern builders, there's no frost line here, right? We don't freeze hardly ever, and we don't freeze for weeks in a row like they do in the north. So we don't have that need for a 2-foot or 3-foot frost footing. We basically can dig right into the grade and we're good to go. That's true for our water lines, that's true for our steel, or pardon me, for our foundation. So this foundation's not going to experience freeze thaw type movement like we would if we were in the north, right?
That's correct, yeah.
Good stuff. Back to the glass fiber reinforced polymer rebar. Did I say that right?
GFRP?
GFRP, yeah, I think that's right. So this is MST bar. You guys actually calced this originally for regular steel. And full disclosure, we normally do regular steel. We kind of did this as a bit of a discovery project for my builders out there that are looking to build this house. This isn't necessarily what I'm recommending. We're doing this as a bit of a discovery project because I hadn't done one before, but I'd read about it for years. Now that we've done it and you've seen it, what do you think about it?
Well, I really like it. I mean, it definitely has advantages for certain applications. We might not be taking full advantage of all of those with a home.
Yeah.
But in particular, exposure to extreme environments, salt water, de-icing chemicals, those types of situations, this is gonna far outperform conventional steel in terms of corrosion protection. One of the best things I like about it is how lightweight it is.
Yeah.
The guys can carry it around the site.
I want to say like 25 or 30% of the weight of steel. And then for us in Texas too, that steel gets darn hot on a summer day with that sun pounding on it. So it just seems like it's much more worker friendly. And I've seen various reports as I've read online that people are seeing savings in labor by using this because it's just so easy. Two guys could move or one guy could move a beam that's all set and ready to go compared to maybe 2 or 3 guys if it was heavy steel.
That's correct.
Yeah.
In addition to that, it has a higher tensile strength than steel, so that's a benefit. And if it had some drawbacks, one, it has a lower shear strength, so we'd want to be careful using this in a dowel type situation. Let's say you were connecting your concrete driveway to the garage using dowels. We would want to use conventional steel for that type of application.
Yeah, that makes sense.
I like the fact too with conventional rebar that it can be fabricated on site, and this cannot. It can be cut to length, but we can't bend corner bars, for example.
That's right. We've got a whole bundle over here of all of our bends and corners and all those other things that we had to order in specially for the job. We can't make one on the job site, right? And we found that specifically in one area. We've got a drop in we got a tire bump is what I usually call it, in the back of our concrete. A lot of times we'd bend that steel in that tire bump. We don't have that. We didn't order that ahead of time. So we can make it work, but it's just one of those small drawbacks you have to think about. Jacob, my concrete guy, had used this a bunch previously in California. And when I told him I was interested in trying it, MST was going to give me a discount on this job. He said, man, that'd be great. I'd love to train my guys up. Interestingly enough, I've heard some chatter that a lot of commercial jobs are moving to it because they want to decarbonize. It takes a lot of energy to make steel, and this, in theory, would use a lot less carbon to make. So I think some municipalities are going to go to it. And then when I was reading about it too, I think a lot of municipalities that have salt water, like Florida, they definitely are interested in this because you don't have that rust issue. As I've been walking the dog the last week or so, I've noticed a lot of sidewalks in town that have some spalling, and you can see that rusty rebar in those pock marks. I wondered if that might not have happened had we had this type of rebar. Yeah,
for sure. And in theory, when you see those situations, oftentimes it's due to inadequate concrete cover over the rebar. So if you place the rebar correctly, the cover should protect the steel. But that doesn't always happen. When you're pouring miles and miles of sidewalk, let's say, it's not unusual for steel to get misplaced.
Right.
So if we had something, so if we had something like this that's not so prone to corrosion, that would be an improvement. Yeah, that makes sense. Now, one of the things that I've been really cautious on this job, I've been really cautious about price and cost for things. So I'm making a note for my builder friends out there. This probably would be somewhat of an increase on this size of job. It may be 20%, it may be 25% on the rebar cost only, not on the whole foundation. But one thing we've done to really bring down cost is we went to a hold down scheme with some Simpson hardware. Let's talk about that for a minute. For shear wall in particular. Yes, so at the garage in the back of the house, we have 2 large punch openings and we have short wall segments. At the rear of the house, we have windows with short walls on either side. Traditionally, we might have used a steel portal frame for our lateral bracing for our wind loads to resist that racking force. And in order, it's a cost-saving measure, and it's a good practical solution. You can build wood portal frames using the correct hardware and the correct nailing pattern. But basically off-the-shelf wood parts, right? Yes, readily available. It's still your OSB sheathing, still your typical wood studs. You detail it slightly different. You'll run your header all the way across the studs. You won't stop it short at your cripples. It'll be a full-length header, for example. But I'm seeing this become a very common detail. I see it practiced a lot, and most structural drawings include this provision. And I've noticed the trades have gotten very accustomed to installing it. It's not a tough coordination item. Yeah, and that Simpson hardware is pretty much off the shelf. It's the ST
HD14, and we're in the garage right now. This is a 2-bay garage. So I've got a garage door here. I've got one in front of Whit. This is a center column that will have some brick on it. And so those straps will get wet set down into the concrete if I don't fall down into the beam here. And then those are gonna connect to my wood framing above. So I actually have 2, 3, 4, 5, 6 on the front of this house. Now we could have done that, as Whit said, in steel. Simpson also makes a, what do they call that? Like a pre-made?
A strong wall, I believe.
Strong wall, I think, is their title for it. Those can be a little pricey. This was really our best cost way to do it. And when we get into framing, you'll see how that works. There's a little bit of trickiness, and we gotta make sure we follow Whit's plans on that. We gotta make sure the nailing pattern is correct. The details are right to get that, because with this huge opening here, when the wind blows on this house, we wanna make sure that racking isn't happening. I miss anything on that detail?
No, sir, you got it.
Whit, I really appreciate you coming out, brother.
My
We got a
pleasure.
couple details that we need to tighten up to make sure we're there, but I think by another day or two, we'll be ready for pour.
Looking forward to it.
Awesome, guys. We'll see y'all later. Guys, always an exciting day when the concrete trucks are here. Now, we did get a bit of a late start. It's 9 a.m. already on concrete pour day. And we had a bit of a start yesterday where we could get concrete of the day we thought we were going to pour. So, always a little bit stressful that we're finally here. I think we've got 4 or 5 trucks in the ground already. Yeah, about 3 to 4 more. I think we're thinking this is somewhere between 85 and maybe 90 total yards. Not a very big slab in the scheme of things. But a couple things I want you to notice when they're pouring fluid. First off, access wasn't great, so we had to get a pump truck. That's pretty normal these days. My business partner Tim's been building for 40 plus years. Immediately pulled up and said, you know, we would have dumped this in the back of the truck back in the day and saved that $2,500. That's not very typical today that we would do it off the back of the truck. The pump makes it really easy to put it all the way around. It also makes it easy to, there's no trees in the way on this particular lot. They're nicely spaced around so we could get that volume wherever we need it to. One thing I want you to notice today, look at the chairing. If you're not familiar with that term, that's the, in our case, we just use some cinder blocks to bring up the rebar. We really want that rebar to be roughly halfway. So we got a 5-inch slab here at the top. We want that rebar like right in the middle. We don't want that rebar sitting on that Stego vapor barrier. We don't want that rebar too high either. Kind of want that in the middle. So in previous episodes, you might have seen people comment, hey, you need to chair that up. We did that. And also we're making sure that our beams are up off the bottom as well. So that rebar really needs to be in the middle. Another detail that I like on this one that my friends at Cog really did on Weaver. If you look at the corners, you'll see a 45-degree bar that they've tied in. That's a 45-degree angle. There's 2 of them there. That helps prevent cracking on those corners as well. So Cog did a real nice job on that. Now, this slab is kind of an easy one in some respects though, because it's getting totally covered. I've got a Atlas insulation slab top coming later, and then 2 layers of advanced X. So stay tuned for that insulation on top of the slab. I think insulation on top of the slab is way easier of a detail than trying to do that on slab edges, which makes it difficult for termite proofing and for a host of reasons. However, though, because that changes our first grade elevation, I want you to notice in the front porch here, see where the guys are finishing concrete right now? They've got a 2x2 separating the front porch from the house. Now, normally you'd have a 2x4 there, right? We want a 4-inch step into the house. But because we've got that buildup on top of the concrete, had we done a 2x4 there, we'd have a really big step into the house, and we didn't want that. We want that smaller, like 4-inch step. So that's why we're using a 2x2 right there at the front porch. And then we're gonna slope that front porch out a little bit. Another detail that I want you to look at, that we talked a little bit about, was there's a curb on the backhand side of the garage. Well, not the back side, the right-hand side. The grade over there is pretty tall, and we wanted some concrete showing, so we got that curve all the way across. And then we're gonna add a curb basically between the house and the garage as well. So as power washing in the garage, we don't want that water backing up underneath our insulation and our silk floor detail. So we added a curb kind of at the last minute.
Other than that, though, it's a big day. It's pretty straightforward. The weather's going to be nice. It's only 74 degrees out right now, which is pretty nice for Texas. And I think the high today is 90. We're going to pour this thing out probably in the next hour. One thing I want to talk about while we're still here, but you'll see it later, is there's a couple ways to cure your concrete. And we're going to choose probably the easiest method, which may not look the best in the end. We're going to use a curing compound on this slab when we're all done, which will help cure out the concrete. Another option is to cover the entire slab with a visqueen, with a plastic basically, so we can lock in that moisture. Or alternatively, we could put a sprinkler on the slab and run that sprinkler for 5, 6, 7 days. We really want that slab to cure a few days before we start working it. Now, today's Wednesday, we're gonna strip forms tomorrow. We're gonna let this slab sit for 4 or 5 days. On Monday, the ready for in package comes. Let's let these guys finish up the slab, and we'll finish up the video here as we finish up this concrete.
Hey, one quick thing while we're pouring, we're wet setting. We could have actually put these in the forms earlier, but they're kind of wet setting. These ST HD14s, we're nailing these into the forms. And this is gonna form what they call a portal frame. For cost reasons, we didn't want to use any steel. We didn't want to buy necessarily the Simpson preformed shear panels. So these straps are going to integrate with our framing, and the Ready Frame guys have a stud pack right here. So we've got some windows in the back of the house. We'll have one here, there's going to be one in the corner, and then 2 on the other side. And this is going to basically make this back wall of the house, it's going to way increase the shear, even though I've got a bunch of windows here. So stay tuned for that in the framing side. Last thing I want to mention, normally we'd be putting J-bolts in on this back side of the house, which is new construction. We decided at the last minute not to do those and drill them later. Simpson makes some hardware we'll show you as we get into the framing episode. So you're not going to see any J-bolts in this foundation. And then on the front part of the slab, where we've got just 5 inches and then we've got the existing slab beneath that, Whit, our engineer, has designed a detail where we actually have to drill down with our Bosch Bulldogs 9 inches into the existing concrete, plus 5 inches on the brand new concrete. So what is that, like 14 inches? Plus our double top plate height, and we're going to be epoxying some all thread down there with some Simpson epoxy that we'll use that as our hold downs. So in effect, we're not putting any hold downs in now. You're going to see those coming later.
Isn't it fun to see this pump be able to reach out everywhere? And it's fun that the operator's controller is fully wireless. He's able to move that thing around and get it right where these guys need it. Makes the job a whole lot easier. We're almost done. We've got maybe 10 yards left. And I have already made one change that I said earlier. I mentioned we were going to have a curb in between the house and the garage. And as we got closer, Miguel, my concrete guy, said to me, Matt, I think we need to wait on that. So we're actually going to form that and pour that tomorrow. So stay tuned for that. So you can see here, we've got a little bit of slope in the garage until we get to the back part of the garage, which we're going flat. We did not do a tire bump on this garage. It in effect allows you to get kind of a double deep. If somebody was doing a project car or they had a sports car, an old MG they're refurbing, that could be in the back of the garage, and then you could still have 2 cars in the front. That's kind of a nice design there. This part here that they're doing with those curbs on the side, it's kind of a pain. That's tricky. You can also see he's got a vibrator going. We really like seeing that vibrator on the job. Vibrating, especially those outside beams and that curb. We didn't particularly try to form this job with board formed concrete in the traditional sense. We did do board form. You've got 2x6s here, but it's a hodgepodge. We didn't try to do it pretty. We'll show you in the back when we start stripping, but let's let these guys finish up. We got a little bit more finishing. It's 11 a.m. I wish that we were done with this pouring an hour and a half ago. I'm not super happy with my concrete batch company today, but we're getting there. It's looking good, and my guys are doing a great job. So let's see the rest of the project, and I'll catch up with you when we start stripping forms.
Poured set and time to strip those forms today. Now, I left yesterday before the guys put the curing compound, but I used my little job site camera to check on it. They did do it. The footage from that showed that it was after 5:30, so I'd already left, but they sprayed curing compound on this entire slab, and you can see it's got kind of a roughish texture. This is not the best texture if you're looking to have a finished exposed slab. This will rough off with people walking on the slab over time. Not an ideal finish though if this is exposed concrete. Now on the other hand, they broom finished my porch. I think this is gonna be fine, even with that curing compound. The garage, I'm not loving the curing compound in the garage, but I'd always thought that I would probably do some type of epoxy. Now yesterday when we were pouring, one thing that I made a bit of a judgment call / mistake on, you can see that we're almost flat between the house and the garage. And right here is where the slope from the garage is happening. So you see that the separation between the house and the garage goes from a little point down to 3 or 4 inches right here. And this wall where my right foot is, this is house, this is garage. So when we frame it, we need to make sure we've got a really good air barrier between the house and the garage. But one thing I was worried about, like back here where the garage slab is basically flat, this wall is separating the house from the garage. I don't love that my slab is flat here, because if someone's power washing or doing something in the garage or frankly just spills something, it could run underneath my bottom plate and get into my house. And I've got a slab top insulation we're gonna show you later, but that concerns me. So what I'm gonna do today is I've got my little mud mixer going, and we're gonna use the mud mixer to make a little curb right here so that we can actually have a little bit more of a concrete separation between the house and the garage. But super exciting. Framing starts next week. The Ready Frame package arrives on Monday. So we're gonna clean up, get the slab looking good, get rid of all the junk and the formwork, try and get it as flat and pretty for the frame carpenters. Guys, this is the end of episode 4, so catch up on the last 3 episodes and stay tuned for framing. This is the Reisinger build with our friends at Builders First Source. We'll see you next time on The Build Show.